All right, third video, and I actually figured out how to get it on the landing screen right away this time. You know, you would think that with the number of times I'm making these videos, with all the mistakes I made, that they'd be amazing by now, but sadly, that's not the case yet. Working towards it though. All right, so solving quadratic equations by factoring. This is our last video. There's only 3 videos for this lesson. This one is on solving a full quadratic by factoring. And by a full quadratic, we mean something that's of this form where you have ax squared plus bx plus c equals 0. So a trinomial. You're looking at a 3-term thing and how we can solve that and use grouping and use all the different things we know, and that's basically all this is about. If you want to pause the video and check these out and look at that, you'll see that these are all just the little kind of tricks and things we learned about factoring these. So I'm not going to spend a lot of time going over these because we're going to kind of use them a little bit. So this first example, oddly enough, you could solve this by using what you learned in the first video. You could solve this by saying, okay, well, I'm going to move this x squared over to the other side, and I'm going to get 49 is equal to x squared. And because I know they're both squared, I can take the square root of both, and then I get x, and then this would be your positive and negative. Oh, sorry, I guess I don't need the radical sign anymore, do I? Positive and negative 7, right? But I want to show you how to do this with factoring. Because factoring, I think, is a little more intuitive, and you're going to use a lot more factoring in general. So you're going to just kind of get in this groove where where you see something, you're like, well, I'm going to factor this. So in order to factor this, hopefully you can recognize that what we've got going on here is we've got a difference of squares going on, right? And remember, a difference of squares is when you're going to wind up with 2 binomials that are going to be the same, except one's going to be positive and one's going to be a difference and one's going to be a sum. All right? So we're going to have that same thing going on here. All right? And so you figure out what your first term is by taking the square root of it. Well, the square root of 49 is 7, so that's going to be my first term. And then the square root of x squared is x. And then you just do your minus and your plus. And that is our difference of squares factored out. And then from here, it's just a matter of setting up your 2 equations, which you should be pretty okay with now. Maybe you haven't done 2 of them that are both binomials, but you know the concept of it, that, okay, I'm gonna set these equal to 0, because I know if this is equal to 0, then it doesn't matter what this is, the whole thing's going to be 0. And vice versa. If this is equal to 0, it doesn't matter what that is, right? Or they could both be equal to 0. So you have 7 minus x equals 0. So let's move 7 over to the other side by subtracting it, and you get negative x is equal to negative 7. Well, if you have a negative, the easiest way to get rid of it is just to multiply the whole thing by negative 1. So a negative 1 times negative x gives me x. And remember, you can do whatever you want with these as long as you do the same thing to both sides. So if I multiply negative 1 by this, I got to multiply it by the other side, which is why I have the whole thing in parentheses. So negative 1 times negative 7 gives you positive 7. So there's one of our roots, all right? X equals 7. And then for this one, 7 plus x equals 0. Well, let's subtract 7 from both sides, okay? Because it's positive right here, so we do the opposite. And then when you subtract 7 from 0, you get negative 7. You now have your 2 roots. So you have x is equal to negative 7 or x is equal to 7. And that is your solution for this particular problem. All right. Next, if I can figure out how to hit the arrow here, 25y squared minus 60y plus 81 equals 45. Well, hopefully you've noticed that by this time that almost all of these have something where it's equal to 0. Well, I need the same thing to happen here. So you've got to clear one side out. Well, it makes a lot more sense to clear this side out than it does to move all this junk over there. That would be a little ridiculous. So what we're going to do is we're going to take 45 and we're going to move it over there by doing the opposite. Well, it's positive here, so we're going to subtract 45 from both sides. So when I do that, this term right here becomes 36, and then we just kind of copy everything else down how it is. And now, if you look at this, I recognize right away, and hopefully you do as well, I'm sure you do, that this is a square monomial, right? 25, square root of 25 is 5. And this is square root of y squared is y. So that's a perfect square monomial. And so is this. All right, so this is more than likely a perfect square trinomial. So let's try it out and see if it is. So the square root of 25y squared is 5y, so that goes on both sides. And the square root of 36 is 6 and 6. And then you determine your sign by looking at this term right here. If that's negative, they're both going to be negative because negative times negative gives you a positive. All right, and then let's just check it, make sure that this middle term is going to be negative 60y. Well, 6 times 5y is going to be 30y, and it's going to be negative. And then you get the same thing over here. So negative 30y plus negative 30y does give you negative 60y. So this is a perfect square trinomial. And what's nice about these is because you get the same thing over here, so that's equal to that, right? They're the same deal. You only have to set up one solution equation. Right? You just set it, you don't have to do it twice. So you get 5y minus 6 is equal to 0. This one is not going to give you a nice, neat answer, but it's very indicative of what you're going to see a lot of times. And then you get 5y equals 6. You divide both sides by 5. And then you get y is equal to 6/5. Now, if you remember, I said the problems that you have one root, right? Those were the ones where the parabola comes down and just touches the x-axis in one spot, right? We also call those a double root. And so now you can hopefully see why it's called a double root. It's called a double root because 6/5 is the solution for this one and for that one right there. So that's why it's technically a double root. Even though we say it's one solution, it is a double root. All right, let's look at this last example here. So just like the last one before, we want to get this side equal to 0. So we got to get rid of this negative 21. We're going to add 21 to both sides. All right, that clears this side out then. Makes this 36, and then you get x squared minus 13x. Well, the first thing I would think is, ooh, do I have a perfect square, another square trinomial? But I know that 6 times x is going to give me 6x, and that doubles 12x. So that's not going to work. All right, so I'm just going to have to do my regular grouping here and figure out what factors of 36 are going to add up to be 13. All right, so you got your x here, and well, if you think about what the factors of 36 are, they're both going to be negative because this is negative, so I know that. Well, negative 1, go away. Negative 1 and negative 36 would make negative 37. Negative 2 and negative 18 would make negative 20. Negative 3, negative 12 would make negative 15. Well, we're getting closer. Negative 4 and negative 9, bingo. All right, so 9, 4, go right in there, equals 0. And now you've got two equations you're going to set up. So x minus 9 has to be equal to 0, or x minus 4 has to be equal to 0 in order for this to hold true. So add 9 to both sides. All right, you get 9, x is equal to 9. Add 4 to both sides for this one, and you get x is equal to 4. And so my solution set in this one would be the numbers 4 or 9. And that is really all there is to this. You will have plenty of situations where you got much uglier trinomials in this, where you got like a number here, and this might be bigger, but then that's just going to be setting up your grouping and doing that. And I didn't have an example for that, but there's plenty of examples of those in lesson 8.6, I believe. So if you don't remember how to do that, go back and look at that, and that will help you with that. So good luck with these and have fun.